All right, so welcome to the second keynote of the day. I'm really excited to introduce our next speaker. But before I do that, I want to make a brief announcement. I want to bring everyone's to attention that ROS World 2021 that is happening October 20 and 21st. The registration for ROS World is actually open now. I know they have a special deal going on. I would love our community to show some support to our ROS partners, and I would love to see all of you over there at ROS World on October 20 and 21st. I know I'm joining, and Drunken Foundation is actually sponsoring the event, so we actually like to see everyone there in October. All right, so it's time for me to introduce the second and last keynote speaker of the summit, Dr. Brian Gerkey, the CEO of Open Robotics, with his keynote, Open Source Robotics at 20. Really excited to have him here. Thank you, Brian, for accepting the invitation. And the stage is all yours. Take it away.
That's very kind, Ramon. Thank you very much. It's a real pleasure to be here and to have a chance to share some retrospective thoughts with the PX4 community. So what I'm going to talk about today is, as the title suggests, open source robotics broadly, not the Open Source Robotics Foundation or Open Robotics, the organization that I work for, but broadly what has been happening in the open source robotics movement over the last 20 years. Because as a community, we've done really quite a lot. And so I'm going to give you a brief tour through some of the things that have happened, and hopefully be making the argument along the way that this is the way that we're building this common infrastructure, doing it in an open way with open standards and open interfaces. It's the best and the right way to build this infrastructure. And I don't think I have to convince this community, the PX4 community, of that, because that's what you're all here dedicated to as well. But I hope that this will encourage you when you go off and start your own companies, start your own new research projects, that you're picking up this open infrastructure and taking it with you. I will mention that because all of you know a lot more about PX4 than I do, I'm specifically not going to address PX4 or the UAV or drone use case. I think you've got a summit full of fantastic content that is specifically about that domain. So I'm going to talk to you about the parallel domains where there's a lot of overlap in the relevant technology, but I'm not going to talk specifically about UAVs or drones. So with that, let's see here. Okay, so how did we get here? It's a real pleasure to be able to look back over such a substantial history that we already have in building open infrastructure for robotics applications. So I'm going to start where I started. This is not necessarily the very beginning of this movement. It's certainly not the beginning of the open source movement, but it may not even be the beginning within the robotics community, although I think it's pretty close. So I'll start in the late 90s. I arrived as a young grad student at the University of Southern California, and I was working in a lab that was overseen by Maya Matarik, and it was closely related to a lab next door. Gaurav Sukhatme was running that lab. And we had a very common problem at the time. We had robots like the one on the lower left, that's a Pioneer 2 from a company that used to be called Active Media and then was called Mobile Robots and then was bought by Adept and I guess is now part of Omron. In any case, the robots came with some software, but that software was all proprietary. It was supplied to us by the vendor. We actually had to pay for it on top of the robot, and we had to use their libraries. It was actually a kind of a variation on C that they kind of modified the way that C worked with macros, which is sort of an odd thing to do. And that was how we had to interface with the robot. And we found this constraining. And like you often do with such software, you find bugs and then you come to realize, well, I know how to write code and I could probably just build my own thing instead of using that thing that the vendor offered me. And it was from that, frustration / realization that we started what became the Player Stage project. So Player is a robot interface server. It's a daemon that runs on the robot. It has drivers in it, which usually are organized in process as separate threads. Those threads talk to devices like the motors for the mobile robot, the laser, the camera, whatever other sensors you had on there, the other actuators, if you put a robot arm on it, a gripper, and so on. And then you wrote client programs and that was your autonomy stack. You would write a client program that would talk to that server. It would send commands. It would get back data. We wrote this really for the Pioneer 2 because that's what we had in the lab. But then pretty quickly, we started to get other robots. Like we got one of the early Segway RMPs. This was an early movement by basically DARPA really created this effort to take the, at the time, very new Segway human mobility platform, chop the top off, put a ballast at about waist height so that the inverted pendulum dynamics still worked, and then make it a robot. And now we wanted to make, we needed to control that robot too. And so we started building in abstractions. And we started saying, well, you know, this software doesn't have to be specific to the Pioneer. It can be generalized so it can control other robots like the Segway RMP. And in parallel, we had pretty quickly, we put the software up on SourceForge because that was a cool thing before GitHub. And then in pretty short order, we had groups from other labs contributing support for their robots. So there was a group that added support for the RWI B21, which is the red trash can shaped robot that you see there. That was, to my knowledge, the very first one where we got external contributions to support it. And along the way, we also built a simulator. It was called Stage. It's still around. Player's still around as well for what it matters. And Stage is a 2D robot, kinematics only robot simulation. And Player and Stage went together. They became pretty widely used. In terms of the players involved here, so to speak, in the upper right, there's a group shot there. You see myself, Casper Stoy, and Esben Ostergaard is at the bottom. We were really the original authors of Player. Casper and Esben went on to found Universal Robots, which did very well. And also shown there, Richard Vaughn, who is the original author of Stage, and Stefan Weber, who helped a little bit around the edges and then ended up starting a surgical robot company called Cassination. Now, that got us the ability to control the robots that we had indoors and to simulate them. But pretty quickly, we wanted to go outdoors. And so a couple of years later, Andrew Howard, shown here, came to the lab as a postdoc, and he wanted to take all this infrastructure we were using and take it into the outdoor domain and start to really work in 3D and unstructured environments. And so one of the first things we needed was a simulator. We needed to be able to simulate those environments because the operational difficulty of going outside and running experiments is so high. You want to be able to do as much as you can in simulation. And that's where the Gazebo project came from. So Gazebo, the simulator that many of you are familiar with today, which is commonly used with PX4, got its start 20 years ago. And it was simulating robots like those Pioneers. There were outdoor versions of those robots, as well as that Segway RMP, because that could happily go outdoors. The human transporter was built for outdoor movement, after all. And so we built Andrew, and together with Nate Koenig, who is my colleague today, built Gazebo. And it was a 3D physics-based simulation with a player interface. So you would take that, again, you would take your autonomy stack as a player client and use it to talk to Gazebo. Gazebo, of course, is still around today. We're now in the process of restructuring it into what we call the Ignition libraries. And so the latest versions of Ignition or of Gazebo are called Ignition Gazebo because they are a way of using the new modularized Ignition libraries to build the simulation of your choice. Now, we weren't the only ones doing this. We put all that code up, GPL'd originally on SourceForge, but there were other groups who were also in the same situation as us, really. Like they had robot hardware in their lab and they wanted to have good software to control it, and they wanted it to be open, and they wanted to share it with the community, and they wanted to get contributions from other groups who were trying to solve the same problem, and they wanted to share the engineering burden of developing that infrastructure and making it as robust as possible. Some of the ones that I think are worth highlighting are shown here. Carmen came out of Carnegie Mellon University. It was the Carnegie Mellon University robot, Robot Mapping and Navigation, I think is where they got the name from. That was based on Reed Simmons' excellent communications library called IPC. Nothing like naming your library after the general concept which it implements, interprocess communication. And much of the groundbreaking work that happened with mobile robots in SLAM and navigation happened using Karman. A lot of the work that came out of the labs of Sebastian Thrun, Dieter Fox, Wolfram Burgard, that work was really done, that was all built on top of Karman. And in fact, the very first versions of what eventually became the Google autonomous car and now Waymo, way back in the day, that was all built on variations of Karman as well. You also had Orca. This came out of University of Sydney's Australian Centre for Field Robotics, or ACFR. This was from a group of folks who had, in fact, contributed to Player quite extensively. And then they found, in their opinion, some shortcomings in Player, no hard feelings. They went off and started their own project they called Orca. Instead of using the custom client server TCP architecture that we had with Player, they built a system on the at the time new ICE middleware from the company ZeroC. There was also Arocos that got its start in the late 90s, early 2000s as well. And the focus, this came out of KU Leuven, and the focus of Arocos was on real-time control. So the problem that they were trying to solve was, how do we write composable control systems in a way that they can satisfy deterministic execution requirements? That became Arocos, which became Arocos RTT, which of course is still widely used today, often in concert with systems like PX4 and with ROS. And then there were a couple of kind of like more special purpose systems. So Moose, M-O-O-S, came out of MIT and Oxford. And their focus there was really on underwater robots. They were particularly trying to develop autonomy infrastructure that would satisfy the compute and communication constrained environments of having robots underwater with, for example, just acoustic modems to talk to each other or to talk to a base station. And that is still around. That is still something that is used to some extent in that, particularly that underwater domain. And then, of course, the best name of all these systems is YARP, yet another robot platform. This came out of Georgia Mehta's group at IIT. And the focus here was on building infrastructure for the iCub. That was a small humanoid robot, which in fact is still being developed and produced by IIT and is widely used in research labs, especially in Europe. And YARP is still the interface for it. Also from Europe, the Cyberbotics, a small company in Switzerland, started developing the Weebot simulator in, I think, of the late 90s. It became widely used in particular with the Aldebaran Now robots, as well as the Sony Ibos. It's a 3D physics-based simulator. And great news for all of us, that's been open source since 2018. Cyberbotics decided to open source that whole simulator. And so now that's something that you can happily use and modify as you choose in your robotics applications. I'll note that of the ones that are still actively used today, I'd say that's Arocos, YARP, Moose, and Weebots. They all have ROS bridges. There are all ways to have those interface with ROS. Now, we started to see commercial interest pretty early, much earlier than I would have thought, frankly. Toby Collette from Auckland University in New Zealand was he was probably the most active early external contributor to Player. He was really helping us develop a lot of the new software for Player, making a lot of code contributions. And fresh out of grad school, he created a company called InRow, which developed autonomous forklifts. It was founded in 2006. And to my astonishment, and sometimes my horror, it ran Player. The forklifts actually ran Player on them, which, as somebody who, as a grad student, had started this project and put some code in it and was using it in the lab, the idea that you would use this to control these big, potentially dangerous machines seemed really foreign to me. But I was also happy to hear that it worked. And he was able to build a successful company, and then that was eventually acquired by one of the biggest forklift manufacturers in the world, Crown Equipment, in 2013. Another early mover in this space, the guys that started the Orca project that I mentioned from the University of Sydney, that's Alex Brooks, Alex Makarenko, and Tobias Kaup. They started a company called Marathon Robotics, which eventually became called Marathon Targets. And they used, at least in the early days, they used that Orca software as the basis for their products. And the niche that they really identified is mobile shooting targets. So they build these basically models of people on mobile robots, and then military services use them for firing practice. And they're apparently doing quite well. They've recently started a new spinoff or subsidiary effort to work on sidewalk delivery robots. I don't know to what extent they're still using the Orca infrastructure today, but that's been a company that they started in 2007, and 14 years later is still running. Now we'll jump forward a little bit to 2007, and this unusual company was created called Willow Garage. Many of you have probably heard about Willow Garage, but I'll tell you a little bit about it. Just very broad strokes. The goal was to accelerate the robotics industry, and to do that primarily through open source technology. The presumption was that at the time that the internet boom of the mid to late 90s or into the early 2000s was really made possible by the wide availability of high quality, interoperable open source infrastructure. And the goal of the people who were funding Willow Garage was to create an analogous infrastructure for robotics, so that the next boom would take off in the same way the internet boom had taken off, this time in robotics, and it would take off by having people who had good ideas for what robots could be used for, making it possible for those people to have ready access to high quality open source infrastructure that they could combine to build their application. It was an R&D lab. There was no need to raise revenue. There was no need to go fundraising. There was no need to generate a return to the investors. The goal was to have impact. Now, we also had fun too. There was that time in 2008 where the company chartered the ZeroG Plane. It was meant to be a perk for the interns that we had that summer, but scheduling delays made it so that the plane flight was after the end of the summer, and most of the interns had unfortunately went home already. But then that meant that they allowed the full-timers like me and others to join the flight. So that worked out just great, because I didn't really care if the interns got to go. I was really excited to go. So you can see me there with a crew cut in the ZeroG Plane, and also in the top right, you can see Melanie Wise, CEO of Fetch, now acquired by Zebra. Now, what were we doing on the open source infrastructure side? As you probably know, what we were building was ROS. So how that came about is that as Willow Garage was getting started, there was a project nearby Stanford called STARE, the Stanford Artificial Intelligence Robot. This was an effort that had a home primarily in Professor Andrew Ng's lab. Morgan Quigley, now my colleague, was one of the main contributors to that project. He was a PhD student working under Andrew. And he was solving lots and lots of different problems on the STARE project. But one of the underlying issues that he kept facing was a need to have scalable collaboration infrastructure. Because this robot, it's very complex. It has lots of sensors. It has lots of actuators. You want to do lots of different things. And you're going to make that happen, you need lots of different PhD students and postdocs and undergrads all contributing to the code base. And so you need a way to divide up your concerns, to allow people to contribute to just the piece that they care about, to have clean interfaces, to allow those pieces to talk to each other, and to allow you to swap in and out components over time. And from that need, he started working on ROS. In fact, in the early days, they were using Player, but they found that Player was fine for a small team or an individual working on a particular project, but it didn't scale well to having a large interdisciplinary team all working on the same autonomy application for a robot. So he started working on ROS, the robot operating system. Eric Berger, who was became the co-lead with Keenan Weyerbeck of the Willow Garage personal robot program, he came over to Willow Garage, and they had this idea to build what became the PR2. They had built the PR1, a precursor to it, as a teleoperated platform as students at Stanford, and they wanted to take that to the next level, have a robot that would be the best-in-class research platform that would be used in every robotics lab in the world. But they didn't want to just build the hardware, because what they saw is that if they just built the hardware, every lab would build their own software. And so what they wanted to do was to also supply software with it. And Eric and Keenan, coming from Stanford, were familiar with what was happening on the STAIR project. And they said, let's just take that ROS thing and really scale it up. We'll make it the infrastructure for the PR2, but we'll also make it generally usable for other robots and other applications. Eric came over and recruited me to join Willow Garage. As a side note, in the early days, there was some discussion of branding, and I really wanted to call ROS Player 3 because we had Player and we built Player 2 at some point. And I just wanted to call it Player 3. I thought we could build on the brand recognition of Player, but that was totally denied, and now it's called ROS. So our main goal was to build software for the PR2, but we didn't want to overfit on the PR2, and so we forced ourselves to always be testing with other robots. So the one that you see kind of to the right of the PR2 there is that's the STAIR robot at Stanford. And then Bosch, their corporate research facility here in the Bay Area, had built their own kind of similar clone copy of the STAIR robot. And those were the main ones that we were testing with. But even just that amount of heterogeneity forced us to not overfit to one platform. We had to make sure that you didn't make assumptions about that you were just running software for the PR2. It had to also work on these other robots. And so what you know now today is the ROS navigation or nav stack. It was developed on those 3 robots all in parallel. And I'll also mention that just from an implementation perspective, we had a real luxury at Willow Garage in having a veritable army of interns, some of whom are shown on the right there. And they not only did they come and spend months with us contributing a huge amount of code to the project, but they also then went back to their own labs and took back the gospel of ROS with them and started to use it in their own projects. And that really helped to spread the use and the adoption, and over time just recruited more and more contributors. So that's how we got the project started. Now what I want to do is spend a little bit of time talking about the impact we've had. So again, looking back retrospectively over all the years that we've been doing this, there are lots of ways to measure impact. And I'm going to take one particular perspective for a little while here, which is what's the impact that we've had on a few different industries where robots are really starting to be deployed into those industries. Everything that I'm going to show you, to the best of my knowledge, either did or does use ROS in a significant way. A lot of these are companies that don't publicize that information, and so it's possible that that's changed. Corrections are very much welcome, as well as additions. It's worth pointing out, if you know this if you're involved in developing PX4, that because it's a permissively licensed open source platform, there's no obligation for your users to tell you that they're using it. And so the way that we find out that people use ROS is they decide to tell us, or we notice in job postings, or there's some other kind of, accidentally released information, but there's no obligation for them to tell us. And so that means that, frankly, I'd always rather have more information. So if you are ever using ROS in your project and you can be public about it, it really helps the whole community if you are public about it. And you say, hey, we're using ROS, or we're using ROS 2, or Ignition, or whatever, or PX4, whatever the platform is. It really helps the whole project and the community for you to stand up and say, we're using it in that cool video that I just showed you. All right. So the very earliest ROS-based robots that hit the market, of course, there was the PR2, and that was our goal. That was really our focus. We wanted to build the software for the PR2. We were about, I think, when I joined in 2008, the goal was to get it on the market by the end of 2008, and we got it out in the middle of 2010. So, not on time, but it could have been later. To our surprise, ClearPath Robotics out of Southern Ontario added ROS support for their robots. They were building R&D robots, and the very first one that they had ROS support for is the version 1 of the Husky, which I'm showing here in classic Canadian snow. And to my knowledge, they were the first outside company to be selling a product based on ROS. Now, in 2011, my colleagues at the time, Tully and Melanie, developed the TurtleBot. And the goal with the TurtleBot was, well, we've got this PR2, that's great, it's fantastic, but it costs $400,000 US. And so if we're really trying to get more people using more robots and more people using ROS to program robots, we need a lower cost platform. And what they did was they took the iRobot Create at the time, built some decks, added a Microsoft Kinect, which was the hottest sensor at the time, put a little netbook in it. You had the TurtleBot V1. That's what's shown here. We've since iterated on that twice. There's been a TurtleBot 2 and a TurtleBot 3. And the TurtleBot 2 and 3 are both still in production today. And globally, we've sold over, our manufacturers who actually do the sales have sold over 15,000 units of TurtleBots across the TurtleBots 1, 2, and 3. So that's a pretty substantial number of robots when you're talking about getting them into education and research markets. In 2012, there was the first, to my knowledge, commercial, that is to say, not intended for education, not intended for R&D use robot, and that was the Baxter. This is a 2-armed robot that came out of Rethink Robotics, and they built the entire software stack on ROS. Unfortunately, Baxter and its descendant Sawyer didn't fare that well on the market, but I still consider this to be a watershed moment for ROS, because this was the first time that we saw a company build a robot that was meant to provide value to an end user who was not a software developer, who was not a researcher, who was not a student learning about robots, but they saw ROS as the best technology to use to make that robot do what it was supposed to do. So it was an internal building block that, frankly, they didn't advertise. Their end users didn't care about it, which is very different from the TurtleBot, the ClearPath Research robots, the PR2. It was very explicitly advertised and presented as, here's a robot that you can use ROS to program. This is a robot that's meant to do a thing, and it just happens to have ROS inside it. And that was I think that was a real milestone for us as a project. Now, in the mid-2010s, we saw what I'll call the rise of the AMRs, or autonomous mobile robots. Now, before this, there were mobile robots in industrial facilities for a lot of years. But what happened in the mid-2010s is, following the acquisition of Kiva, who was one of the biggest players at the time, by Amazon, that was in 2012, there was a hole in the market because pretty quickly Kiva became an internal vendor to Amazon. And that meant if you were not Amazon and you wanted robots to move materials around your warehouse or your factory, there was a problem. There wasn't someone who could satisfy that need. And so we saw a whole bunch of companies come up to try to meet that demand. And I would say, in my estimation, it's hard to get firm data on this. In my estimation, most of the AMRs that are on the market that are not the old-fashioned wire-guided Swiss log type AGVs, as they're known, or the Kiva/Amazon robots are running ROS. A few examples that I'll highlight here, going clockwise from the upper left, you've got Auto, which is a division of ClearPath Robotics. So the same folks who made that robot that was in the snow, now they're making robots that are moving around factories. We'll go down from there to Mir. This is a company out of Odense, Denmark. And then you've got Six River Systems and Locust Systems, both from the Boston area, and of course, Fetch Robotics from the Bay Area. Now, they've deployed quite a lot of robots out in the world. All those robots are in production all the time right now. And it's worth pointing out that they've had good commercial success. So Mir was acquired by Teradyne in 2018 for $272 million. You had Canvas acquired by Amazon for an undisclosed amount. Six River was acquired by Shopify in 2019 for $450 million. And Fetch was just acquired recently by Zebra for $300 million. And Locust, by their own announcements, has achieved unicorn status. They have a valuation over $1 billion. So, if you take the value that the stock market and that companies put on these efforts, which is not the only way to value what they do, but I think it's a relevant way, then they're having substantial impact. And they're doing that, at least in part, by leveraging ROS in the way that they build their products. We also have ROS. We have autonomous robots getting outdoors. So the ones I've shown you before are inside factories, warehouses. They're doing manufacturing and logistics type applications. But the so-called last mile problem has been an area of focus for just about everybody who's involved in delivery for a long time. Everybody wants to find a way to deliver packages, medicines, food, basically anything that you'd like to have delivered to a home or a business. They'd like to improve the efficiency and the reliability. And one avenue to doing that is by using mobile robots. So a few examples here that are using ROS inside. On the left, you've got Starship from the Bay Area. Also from the Bay Area on top, Dispatch, which was acquired by Amazon a couple of years ago. Amazon now calls it Scout, and they're testing that robot in a number of different markets. In the bottom, you've got Kiwi. Unusually for a robot company, they're from South America. That's a company that's headquartered in Colombia. And it's really exciting to see an increase in the geographic diversity of the innovators in this space. We're used to thinking about robotics companies as coming out of the Bay Area or Boston, or maybe a couple of areas in Europe, maybe Germany, maybe Japan, from Asia, but you don't usually think about a robot company coming out of South America, and that's fantastic. And then one of the newer entrants is Robotics. They've been, Robotics as having made the Dynamixel servos, which you've probably built robots from, and they're also the manufacturer of the Turtlebot 3, if you have any experience with that. They are now offering sidewalk delivery and in Seoul, and that robot is in fact all based on ROS 2, which is very exciting because that's where our development focus is, and so we're really excited to see people using ROS 2. Moving into the automotive space, first of all, I'll just because I can, I'll brag that at least one of the vehicles in the DARPA Urban Challenge in 2008, the one from the Austin Robotics team, used Player. I had no idea. I showed up at the competition and I was talking to one of the people from the team, and he told me, oh yeah, that, our car over there, it's all based on Player. And then he told me that because of a software bug, just the day before, it had run underneath an overhang on a building, and it had just cleaved off a very expensive Velodyne laser from the top, and it had clattered to the ground. I was really worried, but eventually they figured out that it was a bug in glibc. And so it was not Player's fault. I was very happy that it was not our fault. Moving over to ROS, we've seen ROS used in automotive applications for a long time. A couple of high-profile examples. You've got Cruise that has been building self-driving and driver assistance systems. They were acquired in 2016 for a rumored $1 billion by GM. And now a derivative of their product is on the market. That's the basis for the GM's so-called Super Cruise, which is an advanced driver assistance system. Their team built at least the original version of their software all in ROS. You've seen them talk at ROSCon, presenting in particular the WebViz visualization toolkit that they built. And now some of the folks from Cruise have left to start Foxglove, and their Foxglove as a company is commercializing that web-based ROS data visualization package. Voyage in the middle on the bottom has been doing passenger service, in particular in retirement communities. These are kind of closed off environments where they can run at low speeds and move people between known locations in a well-mapped area. They were acquired by Cruise for an undisclosed amount earlier this year. We've also got Apex AI. They've been very public about their use of ROS 2. In fact, what they're doing is building ROS 2-based software for the automotive community. And earlier this year, they were able to get their Apex OS product certified according to ISO 26262 as a safety element out of context, up to ASIL D. So that's a very promising move for the future use of ROS 2 in particular, in these mission critical situations where you have rigorous certification, safety or regulatory requirements. And along the way, one of the things that really spurred the use of ROS and open source software in general for this whole community is AutoWare. This is a project that Shinpei Kato started in 2018, University of Nagoya, and he wanted to build an open source self-driving car stack. And he built it all on ROS 1. He and his lab built it all on ROS 1. He went on to start the company Tier 4, which is continuing to develop autonomous driving technology. AutoWare is now It's now backed by its own foundation, which was created in 2018. And I think it's fair to say it's the most widely used open source self-driving car stack in the world. I think if you were to, as a company or a research lab, if you were going to start a self-driving car project today, you would almost certainly just reach for AutoWare and use that and then build from there. Which means in turn, you're also reaching for ROS under the hood, so to speak, and building on ROS. There's work underway in the AutoWare community to port from ROS 1 to ROS 2. It's going from AutoWare.ai to AutoWare.auto. These are just a few highlights. I will quote my friend Dan Panjercic from Apex AI. He said, at Apex AI, we have an internal list of mostly automotive companies using ROS, and the list has 200 entries. So there are a lot more companies out there who are using ROS in their cars. It's just something that we don't know the full details of. There's also the home space. So companies have been trying to go after kind of this elusive, quote unquote, home robot market for a long time. And by home robot, I mean, and they mean something other than the other robots you already have in your house, like a floor cleaner, or you might have a lawnmower, or a dishwasher, or washing machine, and so on. There's lots of, you already have some automation in your house. You may or may not think about it as a robot, but there's been this desire to build something more, something that is more like what we think about sort of philosophically as a robot. It's a very difficult challenge. But that hasn't stopped people from trying. So a couple of efforts that I'll highlight here. One is in 2017, Mayfield introduced the Curry, which is designed to be a family companion, a mobile photographer in your house. It's a great little robot. We've got one in our office. Unfortunately, the parent company Bosch decided to shut down Mayfield after they'd only shipped a couple hundred units. But some of those units are still running, and I think it's fair to say that they were really brave to try to create a new market with that product. Then you've got Sony with their Aibo robot dog, and this was actually introduced in 1999. It attracted a small but dedicated audience, but it also really focused the efforts of a couple of generations of robot soccer enthusiasts. If you were involved in RoboCup soccer when you were in school, there's a good chance that you either programmed or saw people play with Sony Aibos. But they discontinued those in 2006. And then there was a decade where there was nothing happening with Aibo, and people were just kind of servicing their own robots and trying to keep them working. And then in 2018, Sony came out with a brand new edition of Aibo. And this time, completely to our surprise, we didn't know ahead of time, it's all based on ROS 1. So that's we'll call it a high-end consumer product that has ROS 1 inside, which we're, in general, we're just thrilled to see ROS finding a use in these devices that are designed for entertainment and companionship. Those are applications that we certainly didn't have in mind when we were building ROS, and we don't think about those necessarily when we're thinking about what can a robot do out in the world. But I think those are really important applications, and it's really good to see that companies are going after them. And hopefully we'll see more home products coming in the near future. Final application area that I'll talk about is agriculture. Obviously, we all eat. Growing food is a very important part of society and an important part of the economy. And automation in food production has been obviously happening for centuries. But I would argue that there's been a real qualitative change in the capabilities of those systems in really just the past decade. That's where we've started to take some of what we would think of as really robotic technology with significant software capabilities, significant sensing and compute, and put that into the field. So where it can do something useful and make it easier, faster, more efficient, more productive to grow our food. A few ROS-based efforts in this space. Probably the best known one is Blue River Technology. They were really early to market with a vision-guided crop thinning device. And so this is the one on the left-hand side. It's those white pods. Each of them has a camera that faces down. And what they're doing, and there's a human driving the tractor, and the camera pods are looking down at the rows that they're going over, and they're using computer vision to identify the locations and sizes and relative healths of plants, for the most part lettuce plants, and deciding which ones look like the best ones to bet on and which ones should be gotten rid of. And the ones they decide to get rid of, they squirt them with a high concentration fertilizer spray that kills the plant, fertilizes the ground, and you've then thinned out your crop to achieve the desired spacing, and you've bet on the good ones. They were acquired by John Deere in 2017 for $305 million. So that's a human-driven tractor, but of course people are also working on autonomous tractors. And so the shot in the middle there is Bear Flag Robotics. This is where they're making autonomous driving technology that's compatible with the existing machines, which is to say tractors. And they were acquired by John Deere just earlier this year for $250 million. And then a company that's growing, so to speak, really fast right now is Iron Ox. What they're doing is growing hydroponic vegetables indoors with the assistance of robot manipulators. This is they're getting a lot of traction. They've got the produce that they grow is in the markets in some parts of the country, and they just broke ground on a brand new growing facility in Texas earlier this year. Now, I've been arguing that open source technology is totally controlling this industry. That's not to say that there haven't been developments of non-open technology. Those of you who have been around long enough will remember Microsoft Robotics Developer Studio, or Microsoft Robotics Studio, as I think it was eventually called. This was an SDK that Microsoft put out in 2006. And it frankly, it had a lot of cool stuff. There's a whole concurrency system in there that eventually took on a life of its own and was probably one of the best, one of the best things to come out of that whole effort. But in the mid 2000s, there was this point where we had this feeling like, oh no, Microsoft, because this is the old days where we felt in the open source community, it was like us against Microsoft. And we felt like, oh no, Microsoft was going to come in and really take over. And you had Bill Gates on the cover of Scientific American talking about how, there's going to be a robot in every home, and the application would be that it would run Microsoft software. And some of us got kind of worried, but I think in the end, we prevailed with the open technology because we got there first. This was very different from the home computer market, where the entrenched option was the proprietary system, and the open system came later and was a competitor to it. This was really reversed. We had really created the expectation that the technology that we use in robotics would be open, and so the proprietary option was seen as like, well, that has some cool features, but I can't change them and I can't fix the bugs. So in the end, Microsoft made its last release of Developer Studio in 2012. But it's really important to note that a lot has changed since that time. So Microsoft today does a ton of work in open source. Their VS Code tool, which a lot of my colleagues use, is ranked by Stack Overflow as the #1 dev tool, and it's completely open source. It's specifically in our world, Microsoft has put a bunch of effort into porting ROS 1 from and Gazebo to Windows, and they're supporting it there. They're members of the ROS 2 Technical Steering Committee, and they contribute to ROS 1 and ROS 2. So there's been a real shift in how both Microsoft and the rest of the community think about this relationship in the past 15 years. So about that community, I just want to give a general sense of the scale of this effort. So there are lots of different ways that you can measure an open source community. As I mentioned earlier, nobody has to tell us they're using our software. And so what we tend to look at is things that we can measure as side effects of what they do. So we can look at the online services that we host and see how many people are reading our documentation. And there we're seeing, coming close to 2 million people a year are reading our documentation across almost every country in the world. Our highest documentation reader population is in China, with US as second. That was a switch that happened several years ago. We could also look at downloads and see we're serving up, 750,000. We're serving up ROS binary packages to 750,000 unique visitors per month. Pushing 190 terabytes a year of ROS binary packages. So that's all coming off of packages.ros.org, which we're thankful to the Oregon State University Open Source Lab for their help in hosting all those services. So we're talking about a substantial community. To think about that in terms of where we were compared to where we are now, 15, 20 years ago when I was working on Player, we had a handful of core developers. We had maybe dozens of contributors, and we had, I really don't know how many users we had. I mean, hundreds, surely, maybe thousands, but we were really only serving the research labs. So I'm comfortable saying hundreds. With ROS, it's a totally different scale now. We've got somewhere between dozens and hundreds of core developers, depending on how you count them. We have thousands of contributors. And then the users, if you think about those numbers I just showed you, not every one of those unique visitors is a human. I think some of them are robots that are installing software onto themselves from our package server. But I think it's fair to say we've got hundreds of thousands, if not millions, of users. So that's a real difference. And now broadly across the community, the norm is to use open source. And that just wasn't true 20 years ago. So as a community, we really need to be proud of the fact that we've changed how this industry works. We've really changed the expectations so that if you pick up a piece of software and you want to use it, but it's not open, you wonder why. And you wonder, well, where's the open alternative that I could use instead? So what's next? I'm going to speed up here so we get time for questions. Quick preview of our product roadmaps looking at Ignition and ROS 2. So we've got Ignition Fortress coming out later this month. It's got some great new features. We're really pushing generally on more and better cloud support, where we're, for example, headless simulation is important in a cloud context. We're building on a lot of the stuff we've been doing for years in high-profile competitions like what is going on right now with the DARPA Subterranean Challenge. We're improving modularity so that you can use, and now other simulation systems are using some of the libraries out of Ignition in their own packages, and just giving more flexibility, more choices over dynamics and physics and other aspects. For ROS 2, we've got our next release will be Humble Hawksbill. This will be an LTS release happening in May. The theme this time is developer experience. We're really trying, now that we're at basically feature parity with ROS 1 in ROS 2. Not every package is there, but I would argue all the core features are there. So now we're trying to make them more usable. And I also want to, again, highlight that result from Apex of getting to this functional safety certification has really inspired other groups. And so now we're seeing opportunities to push ROS 2 more into automotive, but also into hospitals and into space applications and others. Speaking of space, one more thing, I'll just show you this video.
This week, I was working with some free-floating satellites inside, actually. Whoa! We have one right here. And so we're using this technology to test out new things that'll help us on future exploration missions, namely to the moon and Mars. What we're hoping is to get these robots to be able to maintain our vehicles when we're not around.
So that is the Astro Bee, and there are 3 of those on the International Space Station, and they all run ROS 1 Kinetic, and that's totally awesome. I just couldn't be happier about that. Okay, with that, I'll say thank you, and I'll take any questions. Ramon, should I pick questions, or are you going to pick them? What do you want to do? Okay, I don't hear Ramon, so I'm going to look at the Q&A here and pick some questions. Let's see. So yeah, good question. How long do you think it'll take until the community finally switches to ROS 2 and it overtakes ROS 1 in popularity? The trends are in the right direction. We've got, when we look at package downloads is the main thing that we look at to track that. And ROS 1 is plateauing and ROS 2 is climbing. When will it happen? I think it's hard to put a time frame on it, but I think we're certainly still a few years out. I think that what is hopefully going to finally push people over is that we're not making any more releases of ROS 1. ROS 1 Noetic, which will go EOL in 2025. That's the last release that'll be supported by Open Robotics. And so I think that is I think that will hopefully push people over. So, a few to several years, I think, is what we're looking at. There's just so much entrenched use of ROS 1 that, and frankly, if you're using ROS 1 today in a project and it does what you want, I'm not going to tell you to switch. That may be work that doesn't get you a lot of benefit. I really encourage people to switch to ROS 2 if there's a particular thing they need that ROS 1 doesn't offer, ROS 2 does, or if they're starting a new project, you should definitely start it with ROS 2. Absolutely. But if you have an existing project, an existing product line that you've already QA'd and put out in the market, I can't in good conscience tell you that you should just necessarily go port it to ROS 2 for the heck of it. And because of that, it's going to take at least some more years. Let's see, can I sort this? I'll sort this by popular. Let's see here. Okay. Okay, what is the next milestone for open source robotics, and how do we collectively work to get there? Wow. So I think that the next milestone is going to be seeing our software used in basically in every application. I think we've got these examples. I've shown you a bunch, but there are still some application areas, still some scenarios where there's this presumption that open source stuff is not it's not good enough. It's not high performance enough. It's not secure enough. You've surely all heard that. Oh, it's open, so I can't use it in a secure context, which is just nonsense, but it's a very popular misconception. And so I think the next milestone will be when it becomes, to refine what I said about all applications, I'll say specifically, it'll be when they're a product manager or a government procurement officer or a regulatory agency has no hesitation at all about saying, oh, you built that system which operates in this mission critical environment that has all these security and performance requirements around it, and you built that all in open source software. That's great. I think that was actually the better way to do it. And I'm not going to ask you probing questions about the provenance of your software on the old-fashioned assumption that stuff that was developed in a closet at a private company is somehow better or more secure than open. How do we collectively work to get there? I think we keep doing what we're doing. I think we keep making the technology better, and to the extent that we can decide to put our focus on particular things, I would say put the focus on showing the world those high-profile use cases. And again, this is a call to all of you who are running your own companies. If you are using ROS, Ignition, PX4, if you're using that technology in your product, then shout about it. When you do videos showing off your capabilities, and it may be the case that the fact that you built an open infrastructure is irrelevant to your customers. And that's probably why it's not hanging off your marketing page. You're not saying, hey, and this was built on open source technology, and that's fine. You need to give the best face to your customers that will cause them to come to you for your products and services. But in the background, off to the side, on the community forums, tell the rest of us that you've built on this, because that becomes a use case, that becomes a success story that I can use in talks like this, which in the end helps to convince other people, because it's not like there's some magic line where the software is either good enough or not. It's really a matter of building up enough examples of it being used out in the wild to where it convinces people to say, well, that company over there used it, so maybe I should too. All right, why are there so few, maybe none, drone companies using ROS in production? I'm a non-expert here, but I'll make a guess. I will guess that is because relatively, I think that ROS becomes more useful when you are trying to do more than one thing. ROS, with its abstractions and its general interfaces, is providing more value to you as a developer if you have a platform that is designed to take on different tasks, or you have a software platform that you want to run on multiple robots each, which is a little bit different. And I think that my view of the drone community is that in most cases you have, by good design, you have special purpose applications, and you're trying to get a drone to do one particular thing. And it may be the case that it's just more efficient for you to build a custom software stack to do that. Now, obviously, it's not, given the size of the PX4 community, it's not efficient for you to build your own Autopilot because you're all building on PX4. And so what we're talking about is what does it take to provide value on the autonomy stack that sits on top of the Autopilot? And that's really where ROS can come in. I think that we will get there as we get to more sophisticated, more advanced autonomy applications that are running on the drones. I think that will cause more developers to reach for ROS. How do you fund the development of ROS? That's a fantastic question. If you're under the impression that as a foundation, we just sit on like an endowment and we fund developers and they write ROS, that's totally wrong. We, as a company, we offer R&D and R&D engineering and consulting services. And so what we do, and a lot of what I do, is I go and I talk to customers in government and industry who are interested in using, advancing, applying the software that we take responsibility for, which primarily today is ROS2 and Ignition. And we talk with them, we identify projects, and we work on those projects. And depending on who the customer is and what the project is, that has the side effect of pouring new code out into the ROS ecosystem. So, you know, we by necessity, we are responsive to our customers. That's why, you know, if you follow the development of Ignition, you'll see that it has great support for large underground, poorly lit environments right now. That's not an accident. That's because we're working very closely with DARPA on the subterranean challenge. And the next big effort we do with Ignition might be for a customer in a different domain, and that you'll see us get pulled more in that direction. But the theme throughout all these projects with all these customers is that we find a way to roll as much as possible, ideally all, not always all, but as much as possible of all that stuff that we built back into the open platform in a way that can be used by a lot of people. I saw Ramon come back, and I guess we're getting close to time. What do you think, Ramon?
I think you can keep going.
Oh, all right. Let's see. How do we create better synergy between our communities? Okay, I'll take that. So that I think is, I'm guessing that's between, like, let's say the ROS community and the PX4 community. And I think that there's already, to my mind, pretty good synergy in that, you know, if I look at the PX4 documentation, I see good examples of doing software in the loop simulation testing using Gazebo with PX4. So that seems to be a relatively common thing that people do. I'll also point to some work that, in fact, Open Robotics have been doing in collaboration with Auterion for the last couple of years in making it possible to use some parts of ROS2, in part through the micro ROS project, on the drones. And so making it easier to mix and match PX4 together with ROS2 without having a bunch of translation layers and going through Mavlink and things like that in between. So on the technology side, we're certainly pushing in the direction of trying to get ROS2 more used and more easily usable on the platform, whether that's in the Copilot computer or perhaps even in the Autopilot microcontroller. So that's the technology side. I think for the non-technology side, we do it through having conversations like this. Like, I come and talk at your event, and hopefully you come and talk at our event. I've got the logo up there for ROS World. We'd love to see you all participating in ROS World. In fact, I don't have the full program in my head, but I'm pretty sure there's more than one talk that's going to happen at ROS World that heavily leverages PX4. So I think we do that on the community side as well. Let's see. When will we see an app store for robots as we already have for smartphones? You know, I still have the slide somewhere. I gave a talk in 2009 at the International Joint Conference on Artificial Intelligence, pitching the idea of a robot app store. And it's 12 years later, and there's still not one. I think that this is something a lot of people want to see. Because the App Store for the phone has just been so phenomenally successful, and it just changed everything. I will give you my perspective. I've thought quite a bit about this. I'll give you my perspective on it. I think that the idea of a general purpose robot or a personal robot, as it's called, as an analog to a personal computer is fundamentally flawed. They're a computer. We can define in the abstract what it means to compute. We know we can say what is computable or not computable. Even a phone, which is a physical thing, has a very limited set of interfaces. It has, there's a few sensors and maybe one actuator. It's a very common form factor. And we can really just put that in a box and define exactly what that does. And it really doesn't do that many different things in the scheme of things. Like, you have lots of different applications, but in the end, they just present different colors and sounds to the screen and the speaker, and that's all it does. Whereas robots are way more varied, right? You look at a PR2 versus a drone, and those are just two very, very different things. There's no reason to believe that an application that would run on the PR2 would also run on the drone. That just doesn't make any sense. They're so physically different, and they're so designed to do different work in the world that I think that there's no reason to expect any meaningful crossover at the application layer. Of course, there's tons of crossover at the infrastructure layer, which is what we're talking about in using things like ROS in both cases. But so for that reason, I just don't think that I don't think we're likely to ever see a meaningful robot app store, at least not one that branches out from, more than a very narrow use case for one robot that does a handful of things.
Do you want to take your last question and we can keep going?
Let's see. You know what I'll do? Well, I think in this interface, I'll also just show you guys you may have seen this. This is a movie that my former colleague Dirk Thomas made, summarizing the contributions that have happened to the ROS project over the past decade plus. So it's just kind of a nice visualization of what's been happening since we moved the project to GitHub. Let me resort this list, and I'll take one more question, and it will be, let's see. I'll take the one at the top there that I haven't answered is, what is the killer feature of ROS 2 over ROS? It depends on what you're trying to do. And so from a pure technology perspective, I think it's probably likely one of two things. That's either the new communication architecture. So ROS 1 is very much based around the idea of having a centralized name server and then peer-to-peer communication based on that name server. And that communication protocol that we built, which we call TCP ROS, is very limited. There's almost nothing that you can do to tweak how it behaves. And with ROS 2, we built primarily on an open middleware standard called DDS. And that takes away the need for the central name server. And it also offers you a whole universe of quality of service settings so that you can tweak to decide how the communications between the peers should happen. That can be a double-edged sword, because adding a bunch of knobs to turn means you might need to know how to turn the knobs for your situation. So that's not, depending on who you are and what you're trying to do, that might actually not be what you want. And the simplicity of ROS 1, it could be better for your application. And we're working on that in particular with the humble rollout and developer experience theme. What we want to do is make it so that the defaults are better for more people. But you very well might be in a domain where what ROS 1 does with that limited TCP ROS protocol is just not good enough. And right now you have no ability to change it, and you have that ability with ROS 2. The other thing from a technology perspective I'll say is that if you use ROS 1 a lot, you know that there are nodes which have to be separate processes because they have a bunch of global state, and there are nodelets which can be combined into a single process, but they're different APIs. And that's annoying, and nodelets are not really first-class citizens in ROS 1, and we did away with all that in ROS 2. And so it's now much more straightforward to write a node that it can be in its own process, it can be in a process with a bunch of other nodes, and you can decide at runtime how to put all that together. So you have much more flexibility to decide how to actually deploy your computation onto your platform. That's from a technology side. From a kind of application fit side, I'd say that we have taken one of the things that we did, one of the reasons I should say that we made the painful decision to rewrite ROS from scratch with ROS 2 was so that we could meet the needs of these domains that have safety certification requirements like automotive. And it's my layperson's opinion that ROS1 it would be a very difficult thing to get approved by a regulatory agency, at least in the industries that I'm aware of, like automotive, to be used in a very serious way. And ROS2, because of our decision to rewrite it from scratch, to be more careful with our design documentation, to be more rigorous about testing, to have a better documented software engineering process, all those things, they're not necessarily, they don't on their own produce better technology, but they offer a better framework to understand what the state of the technology is. And that's really important when you're communicating with regulators and making a safety case to say this thing can be trusted. So that's something you get with ROS2 that it's really it's not impossible, but it's much more difficult to do with ROS1. All right, I think that'll be my last question.
All right, thank you. And everyone, thank you for joining Dr. Brian Gerkey for his keynote. And this is the actual last keynote of the summit, but we still have a lot of content ahead of us. So I encourage everyone to take a break, go to the speed networking, go to the virtual booths, and then we'll come back at 10:30 with the next sessions. And we'll keep going until the after party. Talk to you soon.